Welcome to video 2 of our series on solar heat for industrial processes called SHIP. This is developed within the UNIDO project Greenhouse Gas Emissions Reduction in Targeted Industrial Subsectors through Energy Efficiency and Application of Solar Thermal Systems in Malaysia. My name is Jürgen Fluch and I'm head of the Department Industrial Systems at IEE Institute for Sustainable Technologies, located in Austria and being one of the leading research institutes in solar heat for industrial processes worldwide. Together with our team, we have supported the UNIDO project as international experts along the whole project phases. Well, you already heard about the potential of solar heat worldwide and specifically in Malaysia, as we have a very high solar irradiation in the country and an industrial sector structure comparable to industrialized sectors and countries worldwide. But in order to design and operate the optimized chip system, it is necessary to follow a certain standard and a methodology addressing the whole industrial energy system. I mean, it is obvious whatever we want to produce, we need material for our projects and we need energy, well, a lot of energy. This is supplied either mass-free over electricity or solar energy or energy carriers as natural gas in most cases. The energy system uses this to produce the primary product, some potential byproducts, material and energetic emissions. The core of whatever we want to do with optimizing the industry and in the industrial energy system is to get rid of CO2 emissions. And they are mainly caused by fossil fuels, so it's very important to do this so. The methodology for a high-level energy assessment is linked to international standards. You have definitely heard about the ISO 50001 or maybe the European standard EN 16247. And each auditor shall follow these defined steps to ensure the high quality of the output of whatever he or she is doing. So the company knows what to expect and the auditor knows what to deliver. A very good base for the work. Starting the 4 core steps, we do a pre-audit, preparing both the company and the expert, and we are clearly defining the core objectives of the work. And within the second step, we have a look at the status quo of the energy system. So we assess it in all details. This will act as a baseline and an idea generator for optimizing the system. The thermal energy you don't need is the cheapest one, clear. And we don't care if the thermal demand is covered by electricity, even better for solar heat because electricity is the most expensive energy in an industrial energy system. Just looking at the energy bills is not enough. We have to know much more about the performance and the efficiency of the boiler, the chiller or the compressor, for example. And we want to know exactly which process is consuming how much energy at which temperature level and at which time. This serves as the basis for ideas and measures on optimization and especially for the use of solar process heat. The next step is the optimized design of the SHIP system for the remaining energy demand. By this, we avoid to install a system that is by far too high and linked to an energy demand we don't need anymore, maybe in some years. So we reduce the investment costs and it's more economically feasible for the company. As a result of the assessment, we have a long list of ideas. So we have to prioritize them on their economic and mainly the ecologic impact, done within step 3 of the energy assessment. And the final step of your work is to present whatever you have found out to the companies and by this to initiate the real implementation of concrete concepts, including the solar process heat. Be aware, even in case the energy assessment will not identify any optimization measures, the minimum output of such an energy assessment is a valuable basis for future work. Said in confidence, after performing more than 650 detailed energy assessments worldwide together with my colleagues, we never assessed the company with no optimization potential, even if they told us before that they have a really great and efficient system. The energy auditor, hired by the company, will deliver a detailed flow sheet and explaining every single production step and quantifying and qualifying the heating and cooling demand and the supply. So here we see the flow sheet of a beverage industry as an example. I would say it's a nice output, right? You will know how this energy is supplied by existing utilities, you assess their efficiency and recognize high-value waste streams going out of your company. A certified expert will be able to use this data for the generation of a so-called Sankey diagram. visualizing energy streams and the temperature level in your system. And by using this diagram, we also see the unused streams going out of your production, and the bigger these streams are, the more money you lose. So colorful, eye-catching, and the Senker diagram has much information in it, you will find out. So for the optimized design of the solar heating system, we have to jump into the production and want to know each single step. We don't only want to know, we have to know what is going on. How is energy supplied by the utilities? Which distribution system is applied? How efficient is the system? And we focus on the core production steps with a high relevance in terms of process energy demand. Is there excess waste heat coming from the utilities or the processes, and are these streams already used in a waste heat recovery system? As these heat streams are very often available in temperature ranges of 30 up to 100 degrees Celsius, this is the perfect match with the solar system and an optimized system design and operation at the very end. A company can expect from the expert a visualization of the primary energy consumption, the performance of supply utilities, and the most dominant machines. So another nice output of the energy assessment. And finally, we know exactly how much energy each single production step needs. And as a hint, to start optimization, focus on the process consuming most of the energy. You will see that the optimization impact will be maximized. All these steps are necessary to optimize the ship system, a collector field necessary to supply the demanded energy, and a storage tank. You might ask why we need a storage tank. Well, it is obvious that in most cases the production is not scheduled on the availability of the sunshine or the forecasted thunderstorm. So we harvest the energy when the sun is shining, store it in a tank, and use it whenever we need the energy. So this is the core message. You will get the energy when you need it. And in our next videos we explain in detail how this can be achieved easily. My name is Jürgen Fluch, and as one of the international experts of the UNIDO project, I'm looking forward supporting you and answering your question together with the team.